Good evening to all of you. Today we will discuss differential equation of higher order with constant coefficient. Differential equation of higher order with constant coefficient. Let us discuss first linear differential equation of second order with constant coefficients. Only second order and constant coefficient. This is differential equation of second order with constant coefficient. Second order differential equation constant coefficient. Higher order differential equation constant coefficient can be written as dny dxn plus p1 dn minus 1y dxn minus 1 plus dot so on pny is equal to q, where p1 p2 dot so on pn and q. This p1 p2 pn are constant coefficient as chapter says, and q is any function of x only. Function of x only. Especially this q is some special type of function. Some special type of function, which we will discuss one by one. How we solve this type of differential equation? Let us denote dy. Capital dy is equal to dy by dx. It means that capital D denotes the operator, derivative operator, d by dx. This capital D is the derivative operator. D stand for the differential and 1 by d stand for the integration. d2 is the double derivative, 1 by d2 is the double integration. Dot or so on. If dy can be written as dy by dx, then d2y can be written as d2y by dx2. Then this differential equation is converted into this form using this operator, where d2 is d2 dx2 and y, and capital P, capital D is d by dx, y qy is equal to r. And this differential equation can be converted into this form. If r is 0, then differential equation becomes d2 2d plus q y equal to 0. And this type of differential equation is known as homogeneous differential equation. Homogeneous in terms of higher order with constant coefficient. Right? And one thing I want to clear that all the matters taken in this PPT has been taken from this book, Advanced Engineering Mathematics by H.K. Das. You can refer this book. For this differential equation, if roots are real and distinct, if roots of auxiliary equation, replace dy dx by operator d, and if this differential equation becomes d2 plus pd plus q y is equal to 0. Replace capital D by lambda or any other parameter, lambda square p lambda plus q is equal to 0. Solve this second order differential equation. Its roots are number 1 real and distinct, number 2 real and equal, number 3 complex roots, number 4 surds. This type of roots be obtained. If roots, first case, if roots are real and distinct, say m1 and m2, then solution can be written as this form: y is equal to c1 e to the power m1x, c2 e to the power m2x. If roots are real and equal, then solution can be, both roots are equal, then this can be written as in this form. For example, if roots of auxiliary equations say lambda is equal to 2 and 3, then differential solution becomes y is equal to c1 e to the power 2x c2 e to the power 3x. If roots are 2, 2, then solution becomes y1 is equal to c1 e to the c1 plus c2x e to the power 2x. Right? Next, consider the example. This example. Replace d by dx is equal to capital D. Now, this equation converted into this form. Now replace capital D by parameter m. Instead of lambda, he has taken m. Then this differential equation converted into auxiliary equation is this, right? This auxiliary equation gives two roots. The roots are this. If m is equal to this, then solution can be written as y is equal to c1 e to the power 3x plus c2 e to the power 5x. Right? Similarly, consider this differential equation. Convert into this. Now, lambda square minus 6 lambda plus 9 is equal to 0. And lambda is equal to 3, 3. Then solution becomes y is equal to c1 plus c2x e to the power 3x. Remember that you have to write here only independent variable. Independent variable. Check the differential equation. If independent variable is x, then write x. If independent variable is t, then write t. Replace x by t. This is the solution of this differential equation. Consider this problem with condition, initial or boundary condition given by this. Convert this equation, auxiliary equation is given by this, roots is this. Then if roots of equation is given by alpha plus minus I beta, then y is equal to c1 cos beta x plus c2 sin beta x, c1 cos imaginary part into x, c2 sin imaginary part into x into e to the power real part into x. Apply this formula here. Y is equal to capital A. Instead of c1, he has considered capital A. He considered capital A. Capital A cos x plus capital B sin x into e to the power minus 2x. Right? Apply condition. What is the condition? X is equal to 0, then y equal to 2. If x equal to 0, then y equal to 2. X equal to 0, this term become 1. Cos 0 is 1, sin 0 is 0. Y is equal to 2 means A is equal to 2. Then replace in this differential equation A by 2. This is the solution of differential equation with boundary condition. Here are some exercise which are given that you have to solve. Some problem I am going to solve this. For example, consider problem number 3. Problem number 3, auxiliary equation is lambda square minus 8 lambda plus 16 is equal to 0. Then lambda is equal to 4 and 4. Then solution becomes c1 y is equal to c1 plus c2 ax into e to the power 4x. Similarly, consider problem number 5. Lambda square plus 2 lambda plus 2 is equal to 0. Then solution becomes lambda is equal to minus 1 plus minus I. Right? This y is equal to c1, imaginary part coefficient, imaginary part is 1, cos of x plus c2 sin of x multiplied by e to the power minus x. Apply the given condition y0 equal to 0. Y0 equal to 0 means apply here. Y0 equal to 0 means c1 cos 0 is 1, sin 0 is 0. This is 1. Then c1 is equal to 0. Right? c1 equal to 0, then equation can be converted into this form: c2 sin x e to the power minus x, right? Y dash, what is y dash? Y dash is equal to c2 e to the power minus x cos x plus sin x e to the power minus x multiplied by minus 1, right? This is y dash. Y dash is equal to 1 at x equal to 0. In this differential equation, put 1 is equal to c2, right? X is equal to 0, and this part become 1 and this part becomes 0. 1 plus 0, then c2 is equal to 1. Now c2 is equal to 1, then solution becomes y is equal to this solution, put c2 is equal to 1. Similarly, you can solve other differential equation also. If you find any problem, then you can email me or WhatsApp me. Now consider another problem. This differential equation is not homogeneous. Not homogeneous. Why not homogeneous? Since RHS is not 0. Since RHS does not equal to 0. RHS is not 0. This is the boundary condition. This condition is given. Now convert this differential equation into this form. d2 d by dt2 is d2 g by l x g by l into capital L. This form. Note that in this differential equation, x is dependent variable. Dependent variable, and t is independent variable. Right? T is independent variable. Now auxiliary equation of this differential equation is m square plus g by l equal to 0, then m is equal to this. Since this roots is complex, compare this alpha plus minus I beta. Note that alpha is equal to 0 and beta is equal to square root of g by l. In solution becomes c1 cos imaginary part into independent variable is t, not x. c1 cos square root of g by l into t, c2 sin square root of g by l into t, right? This is equal to cf, not x. X is independent variable, but this is not equal to x. Why? Since RHS is not 0. If RHS equal to 0, then this cf become x. Now, how you evaluate pi? Pi can be considered as pi is equal to 1 upon operator. Operator is d square plus g by l, right? Into g by l capital L. What is this? This term is RHS. This can be written as 1 upon d square plus g by l into e to the power 0 into t into g by l capital L. Now for pi, replace d by 0 and this becomes capital L, d by 0. But condition is that provided denominator does not equal to 0. This becomes capital L. Now this is pi. Now solution is CF plus pi. This is CF and pi is capital L. This is CF and this is pi. Pi means particular integral. Particular integral does not containing any arbitrary constant. CF, general solution of the homogeneous part. Right? This is the solution of the differential equation. Now condition is given that x is equal to a at t is equal to 0. Let us consider t is equal to 0. For t is equal to 0, x is equal to a. X equal to a and t equal to 0. Put this condition first. Now x is equal to a, t equal to 0 means this part is 1, this part is 0 plus L, C1 plus L, right? Second term, dx by dt is 0. Differentiate this. Dx by dt is equal to C1 cos minus sine square root of g by L t square root of g by L plus C2 square root of g by L cos square root of g by L into t. Derivative of L is 0. Now if t is equal to 0, this part is 0. If t is equal to 0, C2 square root of g by L equal to 0. This implies that C2 equal to 0. C2 equal to 0 and C1 plus L is equal to A. Then the solution becomes x is equal to, what is C1? C1 is A minus L. A minus L cos square root of g by L into t plus, what is C2? C2 is 0. This is the solution of this differential equation. Next. Consider this differential equation. Now auxiliary equation becomes m square 6m plus 9 equal to 0. Roots is this. Since roots is real and equal, then solution becomes c1 plus c2x e to the power minus 3x. What is pi? Pi is equal to 1 by operator. Operator is d square plus 6d plus 9. 5 e to the power x. If RHS function is only exponential type function, this function is only exponential function. Put that only exponential function. We have to apply this rule. Replace dy, replace capital D by a. What is a? A is coefficient of x in exponential part. Coefficient of x in exponential function. Right? Then coefficient of x is 3. Here a equal to 3. Replace d by 3. But replace provided that denominator not 0. Then d square 3 square 6 into 3 plus 9, that is 36. This is pi and it is CF. What is solution? Solution is CF plus pi. Now note second example. This example number this says that d2y by dx2 minus 6dy by dx plus 9y is equal to 6 e to the power 3x plus 7 e to the power minus 2x minus log 2. Log 2 we can write here e to the power 0x. Right. Now first evaluate auxiliary equation. D2y 6dy 9y equal to this. Auxiliary equation is of this lambda square minus 6 lambda plus 9 equal to 0. M is equal to 3. Then complementary function become this. Right? What is pi? Pi for different functions. Since it is summation, and first we have to calculate pi for this and pi for this and pi for minus log 2. Replace d by coefficient of x, that is 3. Coefficient of x in first term. Coefficient of x is 3. Replace d by 3. Then 9 minus 6 into 3, 18 plus 9. Denominator is 0. If denominator is 0, then what we have to do? If denominator is 0, then multiplied by, suppose 1 of fd e to the power ax is, if fd is, f of a is 0, if f of a is 0, then x into 1 upon f dash d e to the power ax. Now differentiate denominator with respect to capital D. Derivative of d square is 2d. Derivative of 6d is 6. Right? Derivative of 9 is 0. Multiply by x and replace d by 3. In this term, replace d by minus 2. This is 4. 6 into minus 2 is 12 plus 9. This denominator is not 0, then it is okay. Minus log 2. I already told that e to the power 0x. Replace d by 0. 0, 0, 9. 1 upon 9 log of minus 2. Then this is again, if we replace d by 3, then again this becomes 0. And what we have to do? Again multiply by x and taking derivative of this term. Right? Derivative of this term is 2. With respect to capital D, derivative of this term is 2. X square 1 by 2, 6 e to the power 3x. And this 7 by 25 minus log to 1 by 9. This is equal to pi and this is CF. And solution can be written as dependent variable equal to CF plus pi. This is the exercise. You solve it. If you have any problem, then you can email or WhatsApp me again. Second special type of function is polynomial. This is polynomial function. If function is polynomial, then what we have to do? Then FD inverse is converted into binomial form and expand this derivative of this term x to the power n. For particular integral, we use this formula. Now, problem is given that for this concept we have to solve this problem. What is the problem? d2y by dx to a square y a square r by p l minus x. Right? These all are constant. Subject to it, some conditions are given. Then auxiliary equation of the differential equation is m square plus a square is equal to 0, m is equal to plus minus a. Since it is complex root, therefore complementary function is given by this. Now pi, how pi can be evaluated? 1 upon d square plus a square by p r l minus x, a square by r. Then what the formula says that convert FD. What is FD? This is 1 upon f of d. Right? FD inverse means d square plus a square inverse. D square plus a square inverse can be written as d square plus a square inverse equal to 1 upon a square 1 plus d square upon a square, right? Whole inverse. And this is equal to 1 upon a square 1 minus d square upon a square plus d to the power 4 a to the power 4 minus dot so on. Right? Now d square by 4 a to the power 4 is not considered and higher order not considered. Why? If derivative of L minus x becomes 0 for second and higher order, multiply this term by L minus x. D square, what is d square? D square is d2 by dx2. If we differentiate 2 times this term, this becomes 0. Right? Then r by p 1 into L minus x. This is only pi. Right? This is CF and pi. Now apply this condition. What is the condition? y0 at x equal to 0. Put x equal to 0. Y equal to 0. Y equal to 0 at x equal to 0. Y0 x0 equal to c1 x equal to 0 plus r by p into L. Then c1 is equal to r by p into L with negative sign. right? This is c1. Similarly, differentiate this term, put 0 at x equal to 0. You got c2. Put c1 and c2 here, you find the final solution. Remember that whenever polynomial, only polynomial, x to the power only polynomial is present, then take inverse of the operator fd inverse and convert it into the binomial form. These are the some problems. One problem I want to solve, that suppose second d2 plus 2d plus 1y is equal to x. Right? Auxiliary equation is given by lambda square 2 lambda plus 1 equal to 0, lambda equal to minus 1 minus 1. And solution is given by c1 plus c2x e to the power minus x, that is cf. Cf is equal to this. And what is pi? Pi is equal to 1 upon 1 plus 2d plus d square into x. Right? Take inverse of this. 1 plus 2d plus d square whole inverse dx. This is equal to 1 minus x inverse, 1 plus x inverse, 1 minus 2d plus d square plus 2d plus d square का whole square so on x. This is equal to x minus 2 into d, 2. D square of x, mean double derivative of x is 0, then x minus 2. What is pi? Pi is x minus 2. What is cf? Cf is this. Now y is equal to cf plus pi. Cf plus pi, right? Similarly, you can solve other equations also. Consider the different type of differential equation. For example, e to the power minus x cos x, right? E to the power minus x cos x, sorry, e to the power x plus cos x is the RHS. Right? Solve this differential equation. Convert it into auxiliary equation. Replace d by m cube minus 3m square plus 4m minus 2 equal to 0. Right? Solve this. Roots of this equation is this. Now, complementary function can be written as for 1. 1 is only one root. Then c1 e to the power x. Right? Suppose 1 and 1 is obtained. Then this can be written as c1 plus c2x whole multiplied by e to the power x. But only 1. Then c1 e to the power x. What is other root? 1 plus minus I. For this complex root, solution can be written as, since c1 is already considered, now consider c1, c2 and c3 arbitrary constant. c2 cos of x plus c3 sin of x multiplied by e to the power x. What is pi? Pi corresponding to e to the power x and pi corresponding to cos x. 1 upon d minus 1 d square minus 2d plus 2. Right? This can be factorized as d minus 1 d square minus 2d plus 2. Right? Plus this term. Now e to the power x, replace d by 1. If we replace d by 1, then this term becomes 0 and this term does not 0. Where this term does not 0, replace d by coefficient of x. Coefficient of x is 1, replace d by 1. Right? 1 minus 2 plus 2. Okay, this term is 0. Then what we have to do? Multiply by x for this term. Multiply x, differentiating this with respect to d1 e to the power x. Right? And here what you have to do, if term is sine or cosine, if this function is sine or cosine, then replace d square by minus a square. A means coefficient of x. Coefficient of x is 1. Then replace d square by minus 1 square, that is minus 1. D cube can be written as minus 1 in d square into d. The minus 1 into d. 3 into d square, 3 d square can be replaced by minus 1. 3 into minus 1. 4d. D cannot be replaced. Only d square can be replaced. D square, d4, d6, d8. Right? Minus 1 into d. Minus 3 into minus 1, 4d. Let's do. Now solve this. We obtain 3d plus 1. Since it says that d square can be replaced, now multiply by 3d minus 1, denominator and numerator. This term becomes this. Now again, in this term replace d square by minus 1. This becomes 9 into minus 1 minus 1. Minus 1 by 10. 3d. 3d means d by dx of cos x minus sin x. Minus 1 into cos x, then this is pi. Then y is equal to cf plus pi. This is cf and it is pi. Right? Next part. This is the solution. But d square replaced by minus of a square only when denominator does not equal to 0. Right? If f of minus a square equal to 0, this formula is not applicable. Right? Solve this differential equation. D square plus 4 cos 2x. Right? Complementary function is given by this. Since roots is this. Pi. If we replace d square by, here we replace d square by minus of 2 square, and that is minus of 4. Then denominator becomes 0. If denominator becomes 0, then what we have to do? Then we have to do multiply numerator by x. Right? Multiply x. 1 upon and differentiating denominator by with respect to capital D. 2d. Right? 2d cos 2x. Again, since d is not here, then what we have to do? Multiply d by numerator and denominator. X into d by 2d square cos 2x. Replace d square by minus 4. Then x into d upon 2 into minus 4. Right? And derivative of cos 2x is minus 2 sin 2x. Right? And solve this, you find this. Then solution become CF plus PI. These are the some problems related to these. This is related to when product of function is appear, means e to the power ax into some other function. Not in plus. If in plus this will appear, then pi for this, pi for this, pi for this. If it is in plus. But for multiplication for this, we apply this rule. What is the rule? 1 upon ft is equal e to the power ax by x. Then take e to the power ax outside the operator and replace d by d plus a into phi x. What is phi x? It is not any function. It is a special kind of function. Special kind of function means polynomial, trigonometric function, right? And product of some function like trigonometric and polynomial. We will see in other lecture also what type of function is this, but here phi x is a special type of function, exponential function. And what happened? D square minus 4d plus 4y is equal to x cube e to the power 2x. Here phi x is x cube. This is phi x, right? Auxiliary equation of this differential equation is this. Then roots is 2. Roots is repeated, therefore c1 plus c2x e to the power 2x. What is pi? 1 upon d square minus 4d plus 4, 1 upon ft. Ft is d square minus 4d plus 4, x cube e to the power 2x. Since it is product of the function, 2 e to the power 2x outside the operator, 1 upon d plus 2 square minus 4d plus 2 plus 4 x cube, right? Then e to the power 2x, solve this become 1 upon d square e to the power 2x. What is d square? E to the 1 upon d square. 1 upon d square is double integral of x cube is this. Now solution is CF plus PI, right? Similarly, solve this problem. This problem is auxiliary equation is given by lambda cube minus 7 lambda square plus 10 equal to 0. Sorry, 10 lambda equal to 0. Lambda square minus 7 lambda plus 10 is equal to 0. Lambda is equal to 0 and lambda equal to 5 and 2. And CF corresponding to these two roots can be written as CF for 0. CF is equal to C1 e to the power 0x plus C2 e to the power 5x plus C3 e to the power 2x, right? This is CF. Now PI for this, since phi x is this is phi x. This is phi x. E to the power 2x, replace d by d plus a. In this term, replace d by d plus 2. D plus 2 cube this and solve this. We obtain this term. Now d cube. What is d cube? D cube is equal to d square into d. D square can be replaced by coefficient of x. Coefficient of x is 1 square with negative sign, that is minus 1. Then minus 1 square into d, minus 1 square 60. We obtain this term. Multiply conjugate of this in numerator and denominator. We have this. This d square is replaced by minus 1. Right? Then we find this term. 1 plus 7d, 1 into sin x, 7d into sin x means 7 divided dx of sin x. This term. This is pi. Now y is equal to CF plus pi. Right? This is the solution